Welcome to the brief presentation on the MEplus from South. So it's a survey grade GNSS unit. It's got built-in LiDAR. So let's just go and have a look at how we collect and process the data. So we've got a small work area here that's been measured by the unit. So it's my vehicle there, so I've started it sitting on the bonnet of the car and started up the unit, does an initialization, and then the red line is the track that I've walked along. So what we were trying to do is we were trying to do a survey down through the bush here. It's pretty thick bush where there's a track with steps going down through the bush. So doing a survey like this by GPS is not an option. The trees are too big. You're not going to get a fixed status. You could use a robot, but it's pretty thick bush and very steep and winding, so it's going to take you a lot of traverse stations to get through this work area. Or you could use the MEplus that we're looking at now. So the total survey time, scanning time was 5 minutes. So in 5 minutes, we've covered this area here. So once you've all the data is recorded on the TF memory card on board the unit, and when we're in open areas like this, it's using the survey grade GPS to pull the trajectory onto the position of the GPS. And of course, when it goes through the thick bush there, it changes over to using the SLAM for positioning while you're walking through areas with no GPS reception. So 5 minutes. So then you come back to the office, the data's all stored on a memory card inside the unit, pop the memory card out, and then there's a folder here with all the data in, and that's based, the naming's based on date and time for the start of each scan. So you can obviously change that when you're back in the office. So what we do is we open up our processing software here and we create a new project, which is just a name, come to our processing wizard, use a little folder down here to go and select that folder I've just shown you, and then just basically click next. And you can see here, because we're using the RTK mode, it already knows the position of the data. This data here has been collected on Bay of Plenty 2000 using Geoid 2016 heights. So our point cloud is going to be processed automatically and positioned and georeferenced on that coordinate system, Bay of Plenty 2000. And of course, once it finishes that, you end up with what you see here, which is our point cloud, our 3D colorized point cloud, and our trajectory. So because we want to do a survey of this area, removing all the trees and vegetation is quite a complex process. So inside the software here, we've got a whole bunch of tools, but the one you'll really like is the one-click extract ground points. So you just click that, tell it the type of environment, and click go. So we're just going to leave it running real time so you can really see how long it takes to extract the ground surface, which is a pretty complicated process. So it then saves in the folder where this original file was. It saves the data as a LAS file, and then you come and open it up in this other software, which is here. So I extracted just the ground. So you can see here in the point cloud editor software, we've got the same point cloud. So this is the one that's not been filtered. This is the original one. And then if we turn on the ground one, you can see there's the points that were automatically extracted earlier on. So you can see all the trees and everything have been removed. We've just got the stairs and the ground surface. So the next step, of course, is to go and build up a DTM model and obviously get some 3D polylines showing the features we're interested in, like the steps, the footpath up there, and the edge of the asphalt, and all these features that we want to have in our final drawing. So there's a whole bunch of tools in here for doing that. Probably the one you use quite a lot is, first of all, we'll go and create a polyline. So what I did was I went and just traced down one side of the footpath. I'll just show you very quickly, just like so. And then I go and take that line and I go and convert it to an alignment. So you get your normal chainages, zero chainage at the start and the end. And then we will go and highlight, select our one onto our profile here. Here we are. So it's saying that line I've created has a total chainage of just over 7 meters. So you can see here when we control the bandwidth, of the slice along that alignment. So you can see here's the steps here. So it's a process of you just go through and tracing the steps themselves. I'll just leave it there, and then we transfer that data back to our 3D window. So if you have a look in here now, so you can see here that you can see my tracing of the side of the steps there. So you just continue that process all the way down each side of the steps there. So that's one tool that you use for generating the 3D polylines. Obviously, you just use, create a 3D polyline and go and draw around the outside here, the extent of your work area as well. So again, it's just join the dots a lot of the time using either 2D slicing, sectioning, long section profile tools, or just randomly in 3D going along and zooming in and snapping on objects to create your polylines. Another really nice tool that we use a lot is the quick profile. Again, we could have used that on the stairs here, but it's just the quick profile is typically we just do a single line, but you can do longer ones, I guess. And it's just like before. It's just a similar type of tool like I showed you earlier. Now where again you go and trace over the points in your quick profile view, and then just go and transfer them back to the 3D window. So if you see now, you can see now I've started to trace a profile down the center line of the steps there. So you can see extracting 3D polyline measurement information is very, very straightforward. So go and define your, and of course when we're doing all this, we've got layers. So we've got our layer commands here. So you go and create your layers and put all your data on the various layers that you have. So if I just show you, this is what I did earlier. So you can see I've digitized the steps all the way down. There's over 50 steps there. So surveying all that conventionally would take you a long time. And I've traced the footpath up here. If we just turn the point cloud back on, you can see, you can zoom in and see how well we've done at joining the dots. And if you make a cock-up, which is pretty common, you can just go and correct it. So say I made a mistake there, I'll go and move the line over to there. So you can go and move. So you can start moving stuff around. When you go and see errors and mistakes, you can go and correct it fairly quickly. And you just use your snaps commands up here, snapping to entities or to the point cloud or, closest, nearest point and all this sort of. So you've got all your normal CAD snap commands there when you're going around doing all that. And of course, once we've done all that, then the final step is we do our final 3D surface. And of course, we define, the footpath as brake lines and whatever other, polylines that we've created that we want to use as part of our brake lines for generating that DTM. So it's all fairly straightforward. So you can see there anyway, it's all come up fairly clean and fairly sharp. And to give you an idea of the size of the work area, oops, I need to turn on that snaps there. So you can see up here, up here where the car park is. So elevation-wise from up here, we've dropped down just over 14 meters. So it's quite a drop. And in terms of, square meterage, So, you've got your surface areas here, just over 2,000 squares, for this area that we've measured and created some traditional survey deliverables. And if we just put back the original data with all the trees on, you can see it's pretty dense. And of course, the last step is to go and export this data. And of course, we can pump it out as a DXF DWG into our third-party CAD packages. So that's just a brief overview. Thank you very much for listening. And if you have any questions, please contact me.